So let me start out. Here's the summary of the whole story, right? I left Michigan after getting my PhD, went to Jet Propulsion Lab, which is part of a NASA-funded lab, and worked on data mining, and I'll tell you what data mining is in a second, basically analyzing very large databases to try to help scientists figure out what's happening in the data. One of my big lessons learned here is Michigan could have made a hell of a lot of money from my PhD thesis. They just never patented it or commercialized it, because we ended up also using it at Microsoft. What I learned when Microsoft recruited me was that the problem is not data mining technology, but where the data is, how it's stored, how organizations can't use it, how they're doing a horrible job of it. And I happened to witness the transformation of Microsoft from what I call a small company culture to a big company, which was also a big lesson learned. Then I did my first startup with a couple of buddies from Microsoft, Digimine, known today as Audience Science. It was a crash course in business. I had never done my own business before. Learned a heck of a lot. Learned how to deal with boards and managing big teams. But there I learned that the problem wasn't just technology and data and fixing the data problem. It was about helping businesses figure out how to make money from that data. So that led to another company that didn't last long because Yahoo acquired it, which basically worked on deep data mining problems. And then Yahoo acquired it, and I became Chief Data Officer and Executive Vice President at Yahoo. I thought I was going there for 2 years. I ended up spending 4.5 years there. Some of the very exciting stuff we worked on there, I'll tell you a little bit about. But one of the more exciting ones, I'm not going to talk about today because there's no time, which is sort of creating a whole new research area to invent the new sciences of the internet. How do you know a social network is working? How do you know you can believe what you read on the internet? Right? When can you trust something? When should you not trust it? A lot of unsolved problems that are important. After leaving Yahoo, I did Open Insights for a little while, working with a lot of big companies, including Microsoft and others. Then we did my last startup, which is ChooseOn. And if we have time, I'll tell you a little bit about it. But as you can tell, I have a hard time staying away from startups. Oasis 500 is another passion in my life these days. It's basically working with the King Abdullah II of Jordan, to basically create 500 new startups in a place that had no history of technology startups, really. Right? And actually, this morning, we had some amazing discussions on why Michigan couldn't do something like this, Michigan, the state, with Michigan, the university, playing a big role in that. So that's the story, right? What got me into all this trouble is a physical phenomenon, which is, you all heard about Moore's Law, where computation doubles every 1.5 years. Well, data seems to have been doubling every 9 months in the world, right? So it's growing much more aggressively than the ability to compute. The demand for using this data is exploding, right? Every business is an e-business now, which means they have to deal between 10 times to 100 times the data that they're used to dealing with. And it's both government, personal, etc. Internet is everywhere. And important to you, there's not enough talent. So if you actually get out of here knowing something about big data, something about data analysis and algorithms, you're going to make a lot of money. What is data mining? It's about finding interesting structure in large data sets. Structure is a very, very well-defined thing. It's statistical patterns, models, predictive models, hidden relationships. What we can't define is interesting. And I could give you a whole hour talk on why interesting is hard to define. Because if I give you a small data set, you can enumerate so many more patterns than there are data items. And the question is, which ones are more interesting? There's many techniques in data mining. We're not going to get through them today. The reason data mining is important is many interesting analysis queries, things you'd like to ask the database, like which records represent fraudulent transactions if you're a credit card or a bank company? Which households are more likely to prefer this car over that car? Who is a good credit risk? Why are these automobiles in need of unusual repairs, right? Very natural questions to ask, extremely difficult to state in the language of databases, which is SQL, almost impossible. Yet you have the data. We have data that says, here's good, bad customers. Here's people who responded, people who didn't. Can we use that data to drive answers to these important business questions on top? That's what data mining is all about.